freelancing meetup, and we didn't have one last month because we didn't have speakers. So if anybody interested to speak or your friends would like to speak, just let me know, and then we can arrange something for the next time. And so our live stream is sponsored by Polyfill, and they host hack days and hackathons in Edinburgh area and Scotland in general.
Yeah, if you check out product4.io, you'll see our upcoming events. Our next one is the Edinburgh Tourism Innovation Challenge, which is using data from Edinburgh festivals, hopefully the council, the airport, to improve the visitor experience in the city, and that will be the first weekend of October.
Yeah, so if you're really interested in that. Yeah. So, I mean, usually in the meetup, like, you will have people to introduce themselves. Like, do you expect to do that, or does it matter? Right, okay, cool. Like, no. I mean, like, you won't know anybody, you just like talk to them after, and then, because I know a lot of you guys are looking for work, or you're freelancing and interested in new projects, and so maybe it's cool to talk to other people and see what they're up to. And so today we have two talks, and one is this one integrating React into an existing application that Scott and Richard, and they both work at Skyscanner. Oh, I am myself a software engineer at Skyscanner, and then I work for Flight Search, and we mainly work on with React and C#. And then, anyway, so we can kick off with this one. Can you guys ready?
Hello. Thanks. I'm Scott. As Sway said, I work at Skyscanner. My colleague Richard as well. We are going to talk about. We're going to talk about how we integrated React components into our existing monolithic application. We're going to go through the journey of kind of how we started with the smallest possible slice, some of the decisions that we made along the way, and finishing up with a demo, hopefully. So Richard and I, the team that we work in Skyscanner is called the Growth Discovery Team. So our goal is to try and help users find the right content at the right time. This is us at the Christmas party. We're quite a large team by Skyscanner standards. So Skyscanner teams are generally kind of Scrum team sized, 6 or 7 max. We're about 13, spread across Edinburgh and Glasgow. We want to help users understand where or when they want to go, either by showing them kind of recommendations, our map product, or if they kind of type in everywhere or next month, and showing them kind of vague searches. We're a full stack team, which means that we could be working on either part of the website, the front end user interface, some back end services, or data stores that kind of support these features. So here's one of the examples of a component that fits our goal. So the popular destinations in the map panels here. So this is an example of a component that kind of helps users find where they want to go if they're undecided. So this gives me an opportunity to explain a little bit of the Skyscanner website as it currently is, the kind of high-level architecture. So there's a service called the scaffolding service, which services the user's requests. A user comes into Skyscanner, it gets redirected to the right page. The scaffolding provides the header and the footer, but the bit in the middle is served up using ESI tags. So individual teams generally own kind of ESI components or bits of the page. So we own this bit. Sway's team actually owns the bit above. So there's kind of 3 components that you can see here: the kind of the home page as a whole, the search panel, and the popular destinations component as well. So the component that the service that hosts our kind of components we call the browse funnel. So that refers to both the service that hosts these things and the kind of code behind it that contains all of our front end code. So it's kind of a bit of a monolith that's grown arms and legs and wings and tails over the last few years. So we kind of service multiple components on the Skyscanner website. So we've got here the month view, the destination shelves, the map, and the browse view. So it's written in CoffeeScript with a C# backend. We use Webpack as the module bundler, Karma to run all our tests, and Grunt as the kind of task scheduler that puts it all together. So this is so we decided that we wanted to. Our long-term strategy is to break up the monolith into little parts and have like microservices that kind of service individual components. So we kind of wanted that was our end goal, and so yeah, we decided upon that we wanted to rewrite part of it in React, but still have it served up and integrated in the existing code base. So React, it's the JavaScript library for building user interfaces. I'm sure a lot of you know, but it's the preferred web development framework here at Skyscanner. So some people did some research, weighed up like Angular, a load of other kind of options, and came back and said, we've tried all of them, we've researched all of them, React is the one that we're going to support. So what that realistically means is that React will be available on the Skyscanner webpage, like from the client side, from the user's browser, and that there's going to be, there is a lot of ecosystem now around kind of shared components. For example, we have a design system now called Backpack, which it's a shared central library of components. It means that we don't have to worry about implementing a button and making it look like the rest of Skyscanner. There's other things that being the preferred web development framework means, such as infrastructure for building, testing, deploying your stuff. So that's why we at Skyscanner have decided to go with React. Within our team, what we were trying to get out of this is we wanted to kind of speed up our development. Because our code is so big in this component, in this code base, because it's so big, things can have unintended consequences. When you make a change here, it could affect something over there. We wanted to kind of tidy up our code a bit, be a bit more strict by introducing React. We also wanted to kind of make more use of reuse of components. So we've got like I said, the Backpack design system that allows us to basically not have to worry about implementing a button. And these are all written in React as well, so they're pulled in at build time, I think. And yeah, we wanted to clean up our code base. Like I said, we have a lot of unintended consequences sometimes in our code, because a lot of it is kind of hand rolled, a lot of the state management and the presentation. So we wanted to tidy up our code by introducing a cleaner separation between presentation and state. And yeah, minimize bugs as well. Everyone wants to write bug-free code, and so do we. So before we could even actually start writing any code or doing anything, we had a few challenges to kind of overcome. So the first was that it's quite a large code base. Where do you start? Let's just, you could rewrite everything. You'd be there for years, and at that time, like in that time, you've lost the opportunity to keep making new features. So we had to think about that, whether we wanted to tackle the entire ocean or just kind of tackle a small part of it. Also, we needed to fit in with our upcoming work. Like, there's no point in just doing things for the sake of it. Like, although the code is, like I said, it's big and it's a little bit messy in places, it works, and that's good. So if we were going to do this, then we had to fit it in with stuff that we were going to do anyway, so that we had another benefit. But also, none of us had really used React in a kind of enterprise setting before, and part of the reason for giving this talk is because we didn't really find the resources for integrating React components in an existing enterprise application. It's all about kind of, if you're starting from scratch, or if you've got a simple case. We've got some of our applications have lots of interactions that change things over here, or they're quite complicated or have a lot of domain knowledge and business logic in it. So there wasn't really anything that I could find that, or that we could find that kind of gave us, that we could use. And also within our team, we're quite a large team. Like I said, we have 13 members in total, including a couple of designers, product managers, and developers. And we wanted everyone to kind of have an input into this, so that we weren't just like saying, okay, this is what we're doing. We kind of wanted everyone to agree as such. So our first steps, we decided to see, first of all, if it was possible. So this is kind of a theme. What we'd like to do in our team is have a kind of, do a deep dive into something to see what blockers you hit early and hit them early, so that you can learn or change approach or whatever. So so the first blocker, the first thing that we wanted to overcome was finding out whether it was actually possible to integrate this into our Webpack build. And so in our team we have every couple of weeks, every other Friday afternoon is hack time. So you can go and do something, you can make something better, you can come up with a prototype, you can do whatever you like, as long as it's valuable and you're willing to present it to the team on the Monday. So one of my colleagues decided to just add this to our React build, to our Webpack build, add the React library and build a simple test just to see if it actually would blow up in our faces. And it didn't. Great. So then we kind of decided on our approach. We'd look in the backlog, in our product backlog, work with our product owner to see if there was anything that kind of fitted this, like a kind of new component but within the existing library, and get kind of buy-in from our product owner that it's okay if it takes a little bit longer because we're learning something, it'll make us go quicker in the future. And we also had a bunch of team level decisions, like, so the front end code was already written in CoffeeScript, because CoffeeScript was cool a few years ago. React is cool now. So we had to decide whether we were going to continue writing our stuff in CoffeeScript, or whether we were going to use ES6 and JSX. So we decided on JSX because it's nicer. It's a bit ugly in CoffeeScript, and it's kind of the supported way within the company, and it's a bit better. We also kind of thought about how we were going to do our testing. So React uses Jest and snapshot testing. We used Karma, or we still do use Karma, triggered by Webpack. We decided that we would try and get it working initially with Karma, and then once we could write in pure React, then think about something else. But for now, let's just change one thing at a time. Let's do it in Karma. The code structure as well. Like, where should these go? Like, should we put it in next to all the CoffeeScript files? Should we put it in its own folder? We decided to worry about it later. So we put it in a separate kind of React folder, so that there was not going to be a mixture of CoffeeScript and React, but anything more complicated can wait until we can prove it works. So the first thing in our backlog that we could see that would fit this. This is the inspiration map. You get to it from the search controls on the Skyscanner homepage. It basically tells you everywhere that you can fly to. It's based on Google Maps, but we put our own kind of views over it. When you click on one of these pins, then a chart comes out to the side of the page. And although charts are good, we like charts in our team, the users seem to prefer calendars. So we thought, okay, well, we'll try experimenting with putting a calendar on there instead of a chart. So within Skyscanner, we have a really good experimentation kind of framework. There's an entire team dedicated to running experiments and making sense of the results. So you can specify your experiment name, the things that you expect to change, and limit it to a part of the website, and then the other team's service will deal with randomly allocating the users and making sure that experiments don't overlap and all that stuff. So we decided the map was our breeding ground for the first React component. So our approach, thin slice, will include React on the map page, the scaffolding system, service that I mentioned, that's configurable and where you put React so that it doesn't add page weight for no reason. So we thought, yep, our approach would be include React on this page, integrate a very basic React component just to prove that we can get a React component in our CoffeeScript code base to production in front of users. Then add the more complicated calendar component and put it on the side of this map. And then take a look back and see what we could have done better and change that for the future. So this is the first component that we did in React on the CoffeeScript front end and JavaScript front end. It's just an empty div, just to see if we could actually render the map page. So we had, the component being rendered, all that was kind of native JSX. We had karma tests that verified that we could actually test stuff done in this way. We used CoffeeScript with just like create React class, that kind of thing on the front, and we ran it as an experiment. Even though it's an invisible div, we just wanted to see that the act of rendering this React component on the page didn't have any impact to our business metrics, just to verify for ourselves and to understand if it did, then this would be the impact. So yeah, it was a very simple code change in the end. I've deleted this code, so I'm okay showing it. But yeah, simple JSX, empty div, and yeah, within the CoffeeScript bit. So the bit at the top is JSX, and that's the CoffeeScript that we used to run it. One of the things that we discovered was that we had to ignore some ESLint things because we were doing some funky things, and also I had to put React in a try catch because there was a bug where React wasn't present on the page and it crashed the whole thing. But yeah, so that was the simple change that we did, and it's not the end of the talk. It does get a bit better. So yeah, based on the success of not having any impacts to our business metrics, we decided to be a bit more ambitious.
And that's where I'll jump in. Yes, you can hear me. So this was our kind of stage 2. Let's put in this actual calendar experiment on. So smaller one, you can see the bar chart, which was our existing implementation. For users in the experiment, inside the red section there, they would get this calendar instead. Part of this calendar was provided by the Backpack team, the basic calendar shape and structure. We did a small amount of customization to give ourselves these little colored dots to represent pricing, because we wanted to use this for actual flights booking rather than just pure date selection. Yeah, and that was a rendered React component embedded in the middle of what was otherwise just custom rendered stuff using our own sort of hand-rolled rendering. So when we started doing this, we used the React to cover the rendering. We didn't use any significant state management code. We just took basically our existing data model that was used and did a very basic kind of plug and play into the rendering logic for React. It's kind of a minimal change. We weren't doing any kind of stateful component stuff. It was all very simple, very basic connections up to any actions that were going to occur. And so we just rendered that out, a simple stuff with the data kind of flowing down into it from our existing state model and information, using some slightly customized components, and went to see how that would work for us. So, I mean, one of the nicest things that we found was that we didn't really get hit by any unexpected problems, which is always a pleasant surprise when developing with new technologies. We did find that attempting to plug in our existing state and data into the component was non-trivial. That the representation that had worked for our hand-rolled code took a fair bit of levering to get it to a state where React would happily consume it. And it was a bit slower than we thought going in. And part of this was the half and half approach of, on one hand, using the React logic, but on the other hand, having it wedded to an old existing, not exactly legacy, but certainly older system. The basic result was fine, the rendering out worked. We've not currently gone ahead with pursuing it, but that's the way things go with experimentation. Just because your system works doesn't mean users prefer it. And a big important bit of it is being willing to accept when that's the case. So we may revisit it if we think we have a good use case or a good product improvement. But for us, it had fulfilled the purpose of validating, does this work technology-wise? Can we do this as an experiment? Is this practical for us? So the next thing we looked at was our month view. And this is the view that's used for people who are coming to the site who know basically where they want to travel, but they don't necessarily know exactly when. Usually it's people who are price sensitive. They want to find out when's the cheapest time they can get a flight somewhere in a given time period. So, they'll hunt and peck around for dates, that sort of thing. So we were going to switch from the older version on the right, the slightly darker version, into this new one on the left-hand side, using our backpack components and part of our spring clean on the site, which, as you can see, looks like a little bit more like the kind of the more recent Google style of doing front-end UI, a lot more wide open, clean-looking style. And we were going to rewrite it entirely, just for the experiment. In this case, we were going to either serve you the old month view or an entirely new rewritten month view done entirely in React and rebuilt from scratch, which was kind of our big step. So part of the reason that we justified this, as Scott mentioned earlier, in a product sense, was that we had a big initiative from branding and style people to redo the whole site in this new visual style. And that was a big drive across a lot of different trades, a lot of teams coordinating it with varied success at times. And again, with experimenting, we had to validate that these kind of changes didn't negatively impact stuff, which they did at times, and we then had to go back, rework it, and find out why. And also the month view, while it had been perfectly serviceable for what it was originally written for, and using technologies that were fine at the time, it had steadily aged, and we'd found it getting more and more difficult to do new experimentation in it. That the code, also very well suited to what it did, was quite hard to rejig and change in small ways. We also wanted to get the advantage of Backpack. As I said, we had a large part of the calendar component and a whole bunch of other UI components. And if we could start showing that we could pull these in and use them, that would be great, because any time we want to change a page, all we had to spend our time on was the stuff related to our specific change and our specific business need, not just rejigging another table, relaying out more buttons, all this kind of thing, which had always been a small but ever-present time price in the past. We did consider doing it just as a CSS reskin of the old page. That was in fact what we first came to it with. But looking at it, we realized that to get it to look the way we wanted in the new design was going to be really quite time-consuming. That the old system was quite opinionated about how it was going to look. And although doing a full rewrite was going to be quite a bit more time-consuming, just trying to do a base reskin was actually going to be quite time-consuming in and of itself. So we were able to sell the product on our own going, this will be longer, but what we get out at the end will be better, and we won't have left ourselves with something that has another level of legacy code on top of it. So, let's spare ourselves that upcoming pain. And we also wanted the opportunity to make this code cleaner, easier to understand. As a growth discovery team, one of the things we're doing is always trying out new areas on the site. And that means we're always looking to see if there's an existing system, does that still fit with what we're doing? Or should we be handing that off to someone who's more focused on that particular area? And as it happened, there's another team for whom that might be a better fit. So we want to get it into a state where we could hand it over to them and not have to air all our old dirty laundry to them. So that was the hope. So part of our implementation for this was that rather than dumping it into our old monolith system, we wanted to start pulling it out properly. So we built it as a separate NPM package that we would publish to an internal repo using Drone to manage the build. It would have its own separate build pipeline, its own separate test system. It would have versioning. And it would be moving further and further towards the point where this could be an entirely separate service. That wasn't going to be fully separated in this iteration. It would be a lot closer to being something that could be extracted out of this monolith system. And would hope to be a blueprint for how we do that for other sections and for new services going forward. So one of the huge helps that we had in this is that, again, our internal Backpack team had done a reskin of the Create React app that Facebook provides. Just a little bit of customization for tooling and setup for the way that we use things internally. And that gave us a lot of stuff out of the box. It gave us asset bundling, it gave us a local development setup with live reload, built-in testing setup, configuration, linting for all of our code and styles. And it really was as simple as going clone repo, run setup script, start. Okay, you've got a working local component ready to develop from. That's it. There was like 5-6 lines top to have a fully working local setup to develop in, which was really, really useful. And we're very grateful to them for that. So one of the things I mentioned in the earlier iteration, where we tried to integrate it with the older code, was that the state management had been quite painful. So we looked at that, realized that the month view especially has surprisingly complex state interactions. So one of the things you can do on it is you can choose whether you want to only fly direct or not. And when you change what day you fly out on one, whether outbound or inbound, that can change what prices are available on the other leg, because certain airlines will only fly certain days. So if you change to a Thursday, suddenly flights can disappear from the other side that previously existed. And we also are updating our running price and date total at the bottom. So there's a bunch of different components that could all interact with each other and have knock-on effects from a single user interaction. So we realized that was going to have quite a bit of complex user interaction going on. So what we decided to go with was Redux, which is another framework for doing state management. And one of the reasons we wanted it is that it requires you to kind of formalize everything into specific actions. And we really want to use that to codify what all the interactions that could actually happen in the month view were. So there's a clear abstracted out system saying this is what can happen, this is the effect it can have. If you want to see what happens when a date select changes, this is where it goes. If you want to see what happens when a filter is selected, this is what controls it. And the previous code had a lot of that kind of very muddily tied in with itself. And there would be bits that had view on a master model for the whole page. And so it was very difficult at times to track where knock-on effects would come. So Redux starts with a store, which is basically just a plain object, essentially, that describes the state of your application. That store is pushed down into the view, which in our case was React, and renders out based on the information in your state, pretty standard. What happens is any interaction with the view then can generate or dispatch actions, which is to say something has happened which can cause a change in the state, whether it's initiated by the user or by some kind of programmatic behavior. The action is fed to a reducer, and what that does is basically go, I know there has been an interaction that's going to trigger a change. I will take the old state, examine the action and any data associated with it, telling me what happened, and I'll emit an entirely new state. And that means that the action of how your state changes is really clearly managed by these reducers. And that's quite good. It was particularly good for us because it forced us to define exactly what was happening in places and stopped us from doing some of the workarounds that had led to bugs previously. And that was actually quite a useful gain from it. So we did have some problems or potential problems going into this. We had to look at how we were going to structure it. And we had some ideas, we had quite a bit of ideas up front, some of which had to change. We had to look at what exactly were all the pieces of data that actually existed in our state. And that itself was a bit of a task to sit down and like, oh, actually, there's really a lot of stuff that exists here that sometimes was kind of hidden because you could only see it in one place here or there. You could only see it in this specific code that accessed that bit. We had to look at handling asynchronous calls in Redux, which is something that it handles, but which is not part of a lot of the base examples of it, which has a few implications. And that was very important for us because we're doing pricing data, we have to call back to the back end when a user changes, when they change month, this sort of thing. So that was really critical for us. We had to look at stuff like handling translations, formatting of text. I mean, a perpetual bugbear for us is, Vietnamese dong currency, Russian language, which causes UI changes of length and size that if you were just programming in English, you wouldn't have to worry about. But which, because we're a global company, we have to really think about. We had to look at how we were going to structure all of this. There was a few examples to base that on. And one of the things we had to do was consider making custom components. So we got a lot free from Backpack, basic calendar things. But as I mentioned for our earlier change to a calendar on the map, some stuff had to be implemented for us. We also wanted a chart component because the month view traditionally offers users the choice. Not many people choose the chart, but a few do. Enough that it was still worth keeping around. And while there was work being pursued within the company to create a chart component, they were servicing a lot of different needs, and we kind of got to the point where we needed it before it was actually fully available. So we had to spec up one ourselves, which was quite time-consuming. And another big issue for us was that this page had historically, and I can speak very personally on this, had been very, very temperamental. We tried various experiments before about changing the styling, about changing the highlighting of prices, about changing our communications around some of these prices are approximate. You know, we're just giving you our best from our information from the last time it was checked. And very, very often, almost all the time when we made a change to it, it had a negative impact overall in our metrics. You know, less people would book. We had a great example of a feature where we would highlight the cheapest price, which you would think would be useful to users, but had a really negative impact. And as best we could work out, people would see the cheapest price, and if they couldn't fly that day, would be really unhappy about it. Even if they were never going to have been able to get that price, but because it was pushed in their face, they had the anchoring effect. And so a feature that people had been waiting for literally years in the company for us to implement. We did it and went, actually no, that's a less pleasant experience for users overall, it turns out. And again, one thing that's great about working at Skyscanner is we checked that. We didn't make the change without having metrics in place to check whether that was actually a good idea or not. And when we found out we were wrong, we went, oh well, that was weeks of our work, but if it's a bad thing to do, we're not going to do it. So one of the big things we had for this was, is this actually going to work? Are users going to like it? And I said, it's not. Certainly not in the first version. You know, I was very much like, let's prepare ourselves for how big of a pain we're willing to take on this. Let's be super clear about that ahead of time. But we'll get to how that actually worked out in a little bit. And obviously we're doing this because we thought we would get benefits. We wanted to clean our code. Any rewrite could have given us that, but there were a number of things in the React and Redux that we specifically wanted. We wanted to, React encourages you to pull out very clearly individual visual components and containers that control the interactions with them. We used Redux, as I said, to really pull out all the various changes that could actually happen on the page and make sure that these weren't just buried in functions somewhere. These had a clear structural representation in our code, which is something we were keen on. We were able to pull in the Backpack components. That was going to be great for us, and as it turned out, it really was. And one thing we'll hopefully get to show you is the debugging and analysis, because one of the benefits of using a big popular system is that there's a lot of tooling being written by other people, which is the best kind of tooling, which was really, really useful. And I'll show you what I mean. And we hope that users would like it, which is very optimistic. Okay, here's the, can we actually see this? Oh, yeah, I can't actually see that fully, but, so you can see on one hand this is our redesigned month view, and on the other side here's the Redux dev tools, and what they let you do is the state of your application. Let me see if I can, okay. So it lets you see the state and inspect it, and it creates a timeline of interactions as you go along for every action that occurs on the page. And you can walk back up and down the timeline, you can view your state at any period, you can view diffs of the state, you can view the individual actions that were triggered, the data associated with them. And for debugging, it's just an absolute godsend. You know, you can watch every state change in the front end and pick out the exact time that something isn't set quite the way you expected. Which is just incredibly useful. You can see this showing the diff at the moment and all our various named actions in there. So that was a really useful tool to be able to use, and something that, again, to consume this for us basically took us 1.5/2 lines of code added in, and suddenly with a simple Chrome extension we have access to all of this essentially for free. Okay, how do I make it go away? Wow, Black magic.
Yeah.
Okay.
Cool. Yeah, so that was our journey into integrating React into our big enterprise code base. So we took a lean approach. So we were always asking ourselves, what's the most minimal thing we can do to prove ourselves wrong? So that was, does it integrate at all? Can we put a simple div on? Can we integrate the components in the same code base? And lastly, can we integrate a library can we write it as a library and pull it in via npm? We took a risk. So we had to get buy-in from our product owner to say, like, this will make us slower initially while we learn this stuff. It fits in with our product, with our roadmap, with what we want to do, and it'll help us in the long run. So we got buy-in for that, and we took a risk, and it paid off. We did make a few mistakes on the way, but we ran it kind of as an experiment as well. Everything was run as an experiment so that we could quantify the risks and so that we could see the impact that we could have had, positive or negative. We had no major catastrophes, a few minor bugs as we've seen, but yeah, there's a mostly positive reaction, but also we know where we can improve as well, and the code is cleaner and much better for kind of, yeah, if we want to develop on it in the future. And we were also massively helped by our internal tooling. The backpack components that we've mentioned, that saved us a lot of time, but also just being able to reuse things within the same library easier. That massively sped us up. Yeah, and that's all we have just now. So, do we have time for questions?
How did you guys solve the async issue with Redux? Did you use something like observables, or?
So we used one of the libraries that was available out there for Redux actions. I can't remember the exact name offhand. Yeah, Redux Thunks, that was what we used. Which were both very useful and yet a little risky at the same time. So one of the things that we found that we had to do was trigger chains of actions in the front end because of the knock-on behavior. And that's great to be able to do, but it means you get access to the full state to be able to trigger it and access all the information. So it gives you a slight risk of violating some of the walling off of information into different components that React and Redux are good for. So, yeah.
Oh, that's me.
Sorry. Step over to the other side.
Do you guys look at RxJS at all with observables for stuff like that, or?
No, so we looked at a few other technologies for front-end stuff. No, that's not helping.
Turn down the main volume.
Yep. I think I've got mute. Okay. I think we just can't hear me now, but that's fine. Obviously you can hear me. So we picked out the React technology, and that had mostly been, again, the backpack tooling, for instance, had all been based around that. So we'd played around with it a bit during our hack day. So we were happy this was usable and fit to purpose. So once we had that, we decided to just run with it. Yeah, anything else?
So you mentioned you have like a custom create React app. So have you done the create React app eject, or you actually just bundled afterwards?
So the create React app has a layer on top of it for us internally, which is like our backpack React script. And so we're not ejected from that, and our backpack team maintains that internally.
For me, sounds always really like terrible. It's like eject. That's it. Boom.
No, so we're still able to pick up improvements to that, and we get things like upgrades to jest versions, and we pull in the various individual backpack components as well.
Yeah, so an example of the thing that has changed is that we've got our internal ESLint config, which is based on the Airbnb one, but with a couple of changes. I can't remember offhand what they are, but a couple of small changes.
I'm not totally got my question. Oh yeah, do you guys find it difficult to structure React applications? I find it like I've been using Angular 4 a little bit now, and I find it way easier to structure the Angular 4 applications compared to React. I feel like I always have to think about like, ooh, how do I break this up, and where do you guys have those issues here in a big application like this, or?
So the short answer, no. possibly partly due to not having used Angular. I think part of it is just, so we had to think about it, but that was inevitable in doing like a full page rewrite. One of the things that we had to think about was more related to the Redux side of things, and about saying what data is associated with what exactly. And initially we wanted to separate out every individual bit as much as possible for good separation. But we realized that some areas to do with dates and so on, because of the level of knock-on interactions with selecting one calendar affecting other and so on, that some data just had to be rolled into the same reducer, because ultimately it was too tied to each other to really be separate. And we had to fold some stuff back in. But a lot of the time it was really quite intuitive, and it was quite structured around just the React components. You know, the calendar data is in one data area, the filter switch data is in another area.
It gets much easier once you have Redux. The main problem I had was, with states, should I pull them out here? Should I make this one a stateless component? You know what I mean? Those are the questions I kept asking myself.
So that was one of the reasons that we wanted to go with Redux right from the start, was we looked at the complexity and thought, we really want to be clear about what exists where. And so from the demo thing, one of the really nice things it lets you do is look at your overall state. You can see, we do combined reducers from different levels, and so you can walk it like a tree and look down through the various levels. And when you see it like that, it's remarkably clear.
It's really cool.
And it wasn't, so it was time-consuming in terms of boilerplate to connect it up, not on any real complexity, just here's this action, it connects to this, it goes through that container. But the advantages from doing it were substantial, I would say, especially in terms of clarity. I think the upfront time of doing that, the rewards. When we started having bugs, for instance, it was a lot quicker to see exactly where the data was breaking out.
We started in January, thinking about it in January after Christmas, coming back going, this year we kind of want to do this kind of this thing. The month view that you just saw, we put that live fully last week. So it's been kind of a long-running thing. Like, we haven't given it our full team focus. We've had about 3 or 4 people at any one time kind of working on it, while everyone else works on something else, and people kind of rotating out and in. So yeah, the whole journey has been from January until, it's still ongoing actually. We're still now thinking about the next thing that we're going to do, and still working on kind of cleaning up our old code. So yeah, it's ongoing.
And a lot of that time was the full page rewrite for the month view. That was a good sort of 3 months or so in and of itself. From conception to execution to experimentation, that was quite substantial.
Experimentation and testing, is that more like the look of it, the aesthetic feel, or are you looking at, what are you testing in that case?
So one of the things that we say before we do any experiment is we have to have metrics that are going to dictate whether that experiment succeeds or fails, and we have to have a threshold statistic-wise of what kind of significance we expect to get and what kind of time we need to run it through and against how many users to get that data. And ideally we try not to start any experiments unless we already have that worked out. So our usual metrics are things like user conversion, someone who goes and actually leaves the site to book with someone else. And we'll consider others like number of users that interact with a particular feature, or number of users that sign up for a newsletter or similar, depending, and it can vary. But it's usually much more about sort of large-scale statistical metrics once it's been put out in front of users live on the site.
Do you ever watch, one thing I find really helpful when I'm testing is the aggregate statistics might be helpful, but also just watching people use it and see how they actually interact with the components, and where are these statistics actually coming from behaviorally. What kind of stuff do you do on that side?
So one of our designers is quite good about setting that up in our current team, and we run user testing, which is very occasionally we actually get people into the office, but more often we'll send it out to people with a little script to test and see how it goes. And it's interesting to see, but it is worth being very careful about attributing too much to an individual user's interaction.
Yeah.
And we also get feedback. We have a feedback pattern on the site, and we'll have channels that are forwarded to us as user comments about the experiment as it runs.
And swear words as well. Lots of
Occasionally.
swearing. And yeah, we also we use usertesting.com is one of the things that we send folk off to and say, okay, you're booking a holiday next weekend, go. Here's the internet, and it's quite interesting actually to see not just how people behave on Skyscanner, but how they kind of go and plan their entire trip, which is something that we're always thinking about. Is that us?
Yeah. So yeah, I think we can take a break and then you guys probably will taking the badge and then go on what my badge is. And then yeah, and then probably 10 minutes and then we can have a second talk. So before we start the second talk, I just have a quick announcement. So Ali from Spiritus,
Yeah.
yeah, is a healthcare startup, right?
Healthcare, yeah, involving blockchain.
Blockchain.
So we're quite a small startup at the moment. We're currently looking for a front-end developer, preferably with a bit of sort of UX knowledge as well. If you're interested in applying, you can find more details on our website, which is spirituspartners.com.
Yeah.
Okay. Question. What blockchain are you using on?
Sorry?
Your own local blockchain, or are you using Ethereum or?
We're using a combination of different blockchain technologies. Our clients are in healthcare, so it would be a matter of deploying it with in cloud with and with a mixture of public and private blockchains.
Okay.
I'd be happy to chat more about that in person after this.
Yeah, and then if anybody else has,
Yeah, I'd like to. I'm here to identify a Node.js WebSocket specialist who really knows about WebSockets. I've spoken with a couple of people here tonight, very interested. But if any of you are interested, it's just a short thing, but I'd be interested in having a chat.
yeah.
I'm looking for 3JS export, if anyone, 3JS. It's really 3D stuff.
Like WebGL, right?
Yeah, it's
Yeah.
a WebGL
Yeah.
on the line. Just let me know if you're interested.
Yeah. So again, we also have a Slack channel. Like if you follow us on Twitter, and the first tweet that's pinned to the top, it has a link that you can join and invite yourself to our Slack group. And there you can just talk to people.
Yeah.
And it's kind of quiet at this moment, but hopefully more of you sign up and then we can have more active discussion about anything, right? And then also again, this is a very informal meetup. So if there's anything you want to talk about or you don't like the format, maybe it's too formal because you have talked all the time, or is there just some problem you run into like day to day and then you want to bring up and then talk about it, and that's something we could do as well. And just have a chat. It's very informal. Yeah. Anyway, so now we have Tom, who's gonna talk about like the history of JS module and the future of JS module, right?
Yeah. Can everybody hear me? Yeah. Cool. First of all, I'm just gonna introduce a bit of myself. So, as mentioned, I'm Thomas Chmielewski. So I'm not surprised if nobody will remember my surname or first name. So you can find me at megatomchat at Twitter or my website, tomchat.space. Nothing interesting there, but I'm there. What I do in life is just tinker with web, pretty much freelance stuff. And idea today is speak about modules. So everybody use them with Webpack, Angular, whatever, CommonJS, AMD. There's billions of different standards, but nobody actually knows what we are. So I'm gonna try to see where we came from and where we are at. Okay, so a little bit about, in general, history. So ES standards, ECMAScript, and all those things. Patterns, so most basic patterns which we get. Do-it-yourself specs, so CommonJS, AMD, and a couple others. Ecosystem around them. And ES6 finally, pretty much this is what we have, this is what we're supposed to have, and this is what is being shipped in a browser. So 1995, in 10 days, JS was made by Brendan Eich. He actually was hired to implement Scheme, but pretty much as a marketing trick, it was called JavaScript. Year after, what happens, because we wanted to have it as an open standard, we took it to ECMAScript, and ES1 is released. Year after, ES2, ES3. Okay, so this is a weird one. You can call it as a middle ages of JavaScript. ES6, you would expect, right? ES6, if you ever read that spec, it's awesome. It has types, it has modules, and all the awesome stuff. But there's another camp which just ditches that and just wants to fix 3.1. After that, we fight, we get back, we fight again, we get back again, and we release ES5 and ES5.1, which was literally just 3.1, but properly implemented standard. And finally, drum roll, we have ES6 back on track. So all these features from ES4 came back to ES6, and Now, pretty much everything goes quite well. So, for example, ES8, which is 2017, doesn't make much sense, but, well, it does. So it was officially stage 4 draft was approved this June. So we're up on track for this one. And next one is patterns. So by meaning patterns, I talk about really, really simple things. So which are object literals. So everyone probably done this. Really simple one. You have object, you attach some stuff inside, and that's it. This is how you use it. Module pattern. So I managed to find some mailing lists where I'm trying not to confuse the surnames here, because Richard Cornford actually probably was the first one to mention the mention the module pattern using closures, and Douglas Crockford, so that's the author of JavaScript: The Good Parts, actually made it quite popular. And idea is quite simple. Use ifs, which is called I forgot what it's called. Everybody knows that. You surround it with brackets, you call the function straight away, it returns the object, that's it. You have a nice scope. And revealing model pattern. So Christian Hellman is another good guy about JavaScript, and about 2007, he suggests the revealing one. It's pretty much the same model pattern. The only thing which it allows you to do, it's like rename your exports, and it allows a nicer structure around everything. So the pattern itself is quite good. The only thing is you have to change the whole thing. You don't have, like, it gets quite complicated. And now we come to do-it-yourself specs. So pretty much because all the applications started growing, so we started getting like specs from all around the corners. So CommonJS, what it tries to do, so CommonJS is not a spec by itself. So, okay, sorry about that. So CommonJS is not just a module spec. So CommonJS tried to encapsulate server-side, desktop, and all the other applications. And part of it was modules. So this is what it's referred to as CommonJS modules. And what are the pros of CommonJS? So they're synchronous. So because we have it on the server side and on the desktop, it's way much easier to reason about. It's way much easier to load. And everything loads in the right order because it's blocks. We know that it's actually going to be loaded when we need it. Simple and declarative. So everyone's seen as var something equals require, and we do module export. That's it. That's the whole syntax. Require can be called anywhere, so we can do conditional loading, and supports circular dependence. So module A depends on module B depends on module A. What are the cons of this? Once again, it's synchronous. So what's good on a desktop and what's good on a server, it's not good in a browser. You have like different endpoints. You have to load stuff from different parts. It's just blocks. One file per module. Pretty much, I hear really good talk about this. This is why mobile web apps suck, because CommonJS is quite a common standard, and what we end up doing is big, massive bundles, which we try to shape all at once. Browser needs loader or transpilation, so you can have a split code in a browser. You always have to end up like just mixing them up. It's hard to analyze statically, so because we can call require from different spots in code, you have to execute the code to actually see what you're going to need, what you won't need. And yeah, so the other one was AMD, Asynchronous Module Definition. So it originally started as a part of CommonJS, but they just forked out and created their own spec as well. It's completely do-it-yourself, but the whole idea is way much more browser-friendly. And what are the pros? Async load. So you actually can have code split up and load them asynchronously. It utilizes two stages of JavaScript being loaded. So one is actually parsing, and another is like loading. Supports circular dependencies as well. Compatibility for require and exports. So modules can be split, and plugins. So when I was talking about compatibility with require and exports, plugins allow you to actually use CommonJS and AMD. Doing it over the way around, it's really hard. But there are some cons as well. So it requires quite a lot of boilerplate. So if you ever seen define something, you define an array, you have to keep a track of what's going there. All the shimming can be quite complicated. Import libraries need to support it. So where with CommonJS, it's quite easy, require export, that's it. Libraries not written for AMD are way much harder to do it. And once again, even harder to analyze statically. OK, so UMD comes along. So this is like universal model definition. It tries to define another spec, which is based on 2 do-it-yourself specs to actually make stuff work. And well, we're off to the races. So you know all the builders, bundlers, loaders, and all those things? I tried to get all of them. I got to loaders, never actually touched on most of the bundlers. I'm going to try to actually name them out. So we have LabJS, GetScript, NBLJS, KissLoader, LJS, SteelJS, Clean Modules, Little Loader, Script Load, Load Script, Script Load without a space in it, Almond, Yapnope, Curl, Dodger, Gulp, UI, HUD, Script.js, Toast, Require, Load Runner, JS, PM.io, Rob. Those 2, I'm going to touch on them back later again. Lazy load scripts include Browserify, Webpack, even jQuery has its own. And there probably was at least one mate while I was actually naming them out. And now we have ES6. Well, it was supposed to be called ES Harmony. So you remember I was talking about Middle Ages in our JavaScript history? So back then it was called ES Harmony. And if you check some of the older blog posts, everyone speaks ES Harmony. But it became ES6 modules. So the main idea, it introduces a small amount of HTML syntax, and it has a little bit different semantics of how it treats the actual type module. So it always loads in a strict mode. The scope is always scoped to actual module itself. This is not bound to window. It's async, it has declarative imports, and it also has the dynamic imports, but we are still a bit in the spec. OK, so simpler syntax, loads async. So this is where it takes best of both worlds. CommonJS, nice and declarative. AMD, it's async and works in the browser. And can be even easier statically analyzed. And even better support for cycle dependence. So now we're going to quickly touch on static imports and exports. So this is the feature which you actually have now in the browsers. And this is where you've probably seen it in Webpack and other things. So why static? So let's take like CommonJS as an example. We can do conditional imports and conditional exports. So imagine like, especially in NPM world, when we have things like modules which have like 2 lines of them, 2 lines of code, but you conditionally start importing them. It gets quite complicated. That code elimination during bundling. So this is, you've probably all seen like Webpack advertising as doing that so-called tree shaking. So this is what ES6 actually enables us to do quite easily. Because everything is in the static, it allows us to do that tree shaking. This is why you get a Webpack without any Babel plugin already doing ES6 imports. So custom bundling without custom format. We don't have to invent our own another spec once again to actually bundle it up. The good example about this is Rollup. So Rollup is actually using ES6 static imports and exports to just bundle everything way much more nicer. It's faster lookup of imports. Everything is in a global scope, and plus we know where it's coming from, makes life easier. And variable checking. So you have scope, you don't have to worry where the hell it actually came from. And it gets us ready for macros and types and makes interlanguage modularity easier. So if you ever seen things like WebAssembly, ClojureScript, those are typed languages. And it's way much, JavaScript state by itself like ES5. It's quite hard to analyze and have types. Whereas with our static analysis, we actually can way much easier reason about what types are going to be imported. And let's talk about import syntax. So we have default, namespace, named, rename, empty, and empty. So default, so as simple as that, you import one thing. We can rename named imports. We can just cherry pick whatever we actually need. So we have multiple exports, we can have multiple imports. We can mix and match a little bit in here. So we can rename and import cherry-picked modules. And we can do import bar.js. So this one is quite a good one, because what you can do, you can load up your polyfills, you can load up your global event listeners. It just executes the code, executes the model straight away. And for the export, so we can mark them inline, do it at the end, rename at the end as well, and do re-exporting. So this is quite a weird one, but it makes sense. So straight in place, just declare and export straight away. Create a couple of variables and export them at the end, and rename. And this one, so what we can do, so for example, we have multiple exports. You can just concatenate them and export in one single thing in our module. And these share similarities between themselves. The idea is that they have to be at the top level, so you can't put them in any blocks, you can't put them in any curly brackets, so no conditional loading or exporting. And they are hoisted, so what it means, okay, so have to be at the top level, you can't do this, and hoisted means that imports defined somewhere at the end of a file still will be executed first. It's the same as JavaScript functions work. They always are hoisted, and you always know what function is going to be called. Okay, so the previous two standards, CommonJS and ES6, they're quite different about how they imagine models. It's pretty much how they actually see it. So copies and views. So CommonJS, we have a copy of exported module. And ES6 read-only views of exported values. Let's see an example a little bit in here. So idea is that if we export counter as an attribute and a counter as a function itself, it doesn't have any access to the module itself, but we can modify the counter. In ES6, on the other hand, counter can actually affect the variable inside the module, but you cannot actually modify the variable or attribute in imported module. One thing for you can actually override the counter. So has anybody actually using like const in JavaScript? So what you can do, const, it's actually supposed to be const, but if it's an object, you can override the insides of the object. So it's roughly the same idea. You can actually touch the things itself, but you can tweak about in it. And we have a dynamic spec. So dynamic spec is still in spec. A couple of people tried to implement it, but main idea is that we have a loader interface, and it defines a couple of methods. And it has a loader register. This is where you actually get your packages from. And everything is attached. That system loader interface is attached to the system, which is exposed in a browser. So in a browser, you're supposed to be doing system.import, system.resolve, system.register, whatever you need to do. And here we go. We have system.js. So as we've seen, the same idea of bundling. GSPM.io. So I mentioned this one. It came along, and it states that it's a package manager using system.js universal module loader built on top of the ES6 module loader. The only thing it's missing here, ES6 module loader Polyfill. So this means that it's not actually the loader, and take into consideration that the spec itself, it's still a bit flaky. And what it does, it pretty much does everything we need. Has anyone actually tried system.js and GSPM.io? Okay, so it does real amazing things. You can import stuff from GitHub, and it can do transpilation in a browser rather than Node. Okay, so you imagine when you're actually running your Node, it runs Babel, and you do your live reload. It actually loads Babel in a browser and does the stuff in there. And when you need to import, you can, as I mentioned before, we have registries. So registry itself can be registered as something from GitHub, something from NPM. So you don't actually have to install things. It does everything for you. Story goes from here. It's like one ring to rule them all, right? ES module loader Polyfill. So as I mentioned before, system.js and GSPM.io is based on ES module loader Polyfill. But looking for it, there are a couple of weird things. So it's roughly based on the API, but with a couple of adjustments. And it actually follows unspecified what WG changes and Node.js ES module adoption. So like we're kind of not listening of actually what's going on. But guess what? So in April, what happened? So the actual what WG loader spec, they just put this little note about it being quite deprecated. And if you quite read through it, we're actually waiting for people to implement stuff like import, which is another committee which has to implement, which is like TC39. And, well, we don't have any friends. So what about Node? So situation in Node is, OK, so we had a CommonJS standard, but we had modified CommonJS standard. So with modified CommonJS standard, we have to modify the module system as well. There is really nice plugin, which is standard ESM. It's actually supported by Node itself. But it has a caveat, which is we have to use .mjs. So this is the reason, because we are using CommonJS. We have, like, it's really hard to reason about how it's actually going to work. Good thing about this is you actually can't opt out, but there are some like side effects on this. It works down to Node 4, and it has 0 dependency packages. So it's quite a good thing. And a little demo. OK. OK, so I'm not going to a big, massive, like, I don't know, live coding session. But all I want to do is about stuff being async and sync in a module. So this is pretty much my first demo. So like usually what you expect, I have a module script in a head and non-module script at the bottom. But what happens if we load this, the bottom script technically should execute last. But what we get is actually executes first. What else it does, it attaches this to being in window, whereas module has its own scope. So we have false. All it is undefined. OK, so once again, we're getting back to the all the scoping thing. So as I mentioned, so we have let, const, and var at the moment. So var usually had quite a lot of problems of being like in different scopes, and it was quite hard to reason about. But even now, with having it in the modules, it's not in the scope anymore. So it's quite nice because, well, it's not global. OK, so this example is a little bit more complicated. So as I mentioned before, we can import and execute straight away. So we can pretty much attach polyfills. We can attach our global event listeners and stuff like this. One thing for which I think is pretty cool, because your polyfills, you don't have to do that much of like shimming and polyfilling, simply because you don't have to do so much feature detection. Because if your browser already supports modules, you already know that it's like decent enough browser to support stuff like arrow functions and some other things, which sometimes you need to transpile for older browsers. We can import stuff from third-party libraries. And once again, we can define, so this one, it's pretty much sets at root of my application. OK, so as I mentioned before, import magic, loads my app. So do we have jQuery in a scope? Nope. Sorry. Oh, yeah. So in a module scope, yeah, it exists. It's functioning there. Does it exist in global? Nope. Does X exist? Nope. Okay, and a last small demo. So in here, I just want to show about fallbacks. So besides adding a new besides adding a new attribute, which is like type module, we also get type no module. So this is our fallback mechanism. So it's pretty nice because, so for example, if you had something being transpiled with Webpack, you actually can stop transpiling it and just load it as it is, but transpile this stuff and load it with no module attribute. This means you have quite a nice feature support for browsers which actually don't support it. And idea is, okay, so this is bad. So if I reload this one, nothing happens. But if I launch a browser, which is 8,000?
Yep.
Disable 2 modules. That's all it is. Okay, and what are my slides? Oh, are they? Awesome, thank you. Okay, and so about the support in the browsers. So Safari actually, I noticed that quite a long ago and was quite surprised. Safari actually released it like in winter or so. It's not in a flag, it's in their stable release. It works there. It's actually the only one which I had the least problem with. But with one caveat, no module is not supported, which is like quite weird. With Chrome, so if you're using Chrome Canary, which it's always nice to tinker out, it has it by default. It's not behind the flag. And actual Chrome, it's still in Chrome flags, experimental web features in Firefox 54. So all the Firefox versions have it behind the flag, so Nightly Developer and Firefox Beta as well. And Edge 15 and I think 14 as well had it behind the flag. And there are quite a few credits and like links which I actually used, and they are probably not all of them. I'll try to put all of them once actually. Those are the ones which I actually referenced the most. Any questions? That's me. No questions. Yay. Either I sucked or I just represented stuff really badly.
Can you put a link to your Slack somewhere so people can reference to it? Yeah, just the link to the slide.
Oh, the slides itself in the slide. Yeah. I'll try to do it. I'll just have to get rid of all of my notes because they're a big pile of mess now, I realized, and haven't helped me at all.
It's really cool and it's really useful.
Yeah, cool.
Just
Any questions? Yeah.
So available in Chrome, Canary, or behind a configuration flag, Firefox behind it. Basically, when is it going to be like? Do you know when it's going to be on the web? The JS modules, like in the regular release of Chrome and the regular release of Firefox.
Haven't checked on that, to be honest. The only Safari supports it. Other ones are on the way. So I would say like maybe like next couple of months. Because thing is, so ES8 are landed in draft 4 stage. So this means this is the whole features which are approved and browsers have to implement. So they're like 2 versions behind them. So I would say like maybe I would think it'll be before the Christmas and stuff. We're gonna have modules in all the browsers.
So I have a question. You mentioned Node.js. Can you use the new model system with Node.js, or do you have to use Chrome.js with Node.js?
No, so as I mentioned, you have ESM. So because they had their own standard, they had to re-implement and rethink about how they're going to implement it. So ESM, it's a plugin. It's 0 dependencies. All you do, you load in your index.js, you say require standard ESM, and that's it. After that, you use files with extension .js, MJS, yeah, MJS, .mjs, and that's it. It just works.
Okay, and then you can use import query.
Yeah, it's actually supported from Node 4+, so it's quite well written. The guy who wrote it is JDD, I think. He's the creator of Lodash. So he was working on that for quite a while, and it actually was first implemented in Meteor, if everyone actually used that. And they just took it out from there and implemented it in the node.
So is it faster, like doing it this way versus doing your Webpack thing and having it transpiled into?
Do you mean node or, okay, so do you mean?
So sorry, the modules, if you do the modules in the browser, instead of kind of requiring them and putting them into a bundle.
Yeah, so being a bundle and non-bundle. So if you're using CommonJS, the main problem is being heavy. So if you load all of your dependencies in one package, maybe 2 of them, but usually it's going to be a one big massive bundle. This is what Webpack does. It's way much more relevant for HTTP 1, where actually initiating connection is way much more expensive. So the whole latency network is connection is expensive. Afterward, it's fine. Whereas, especially with HTTP 2 kicking in and stuff like the server push, you have one connection, so you don't have that initial like kickoff start with the network. And this is where it's going to really, really win. You're going to have it way much faster. Another thing, you don't need transpile. So because at the moment, what's done, it's just all the transpilation in your steps. So you don't need to do that anymore. So it's already your building pipeline is way much smaller. Rather than bundling, analyzing, you just, oh, we can do it by single module. So yes, it will be way much faster.
Do you know if they do any caching on like common chunks? You know, like with Webpack, you have like common chunk splitting, so they do some kind of performance optimization if you require both of them are including the same chunk, same.
Yeah. So what we actually do in a Webpack, there is really, really good talk about Webpack. I'll try to put it somewhere. Where it explains all Webpack does, it actually fits on one slide. You would be surprised. And all it does with the caching is just an array. And just, oh, if it finds the same required, it just refers back to that same index. It's so simple. You don't have to do it anymore because it's all static. There's no more like dynamic stuff. So you don't actually, because you don't have to, as I mentioned, roll up as well. So you don't have to invent those caching and bundling compression formats. Simply because it is static, so you can split it up, and you can just load it from that file. The main thing with Webpack, you have everything in, you can, CommonJS, and you just load from there. But in here, you can split the files up already. You don't have to make them common, because you just import always from the same thing. I know. Any other questions? Nope. Yeah, thank you very much.
Thank you, Tom. I think that's a really good talk. I think both the talks really good. And they set like really high bar for the quality of our talks. But usually I think everybody can share whatever they learn or the project they're working on. Or, we can just have a discussion like what was earlier.
Guys, I learned this on a go, and I literally made this talk in 3 days. I knew nothing about model.
You're a little bragging. Yeah, anyway, so if anybody want to talk or anybody want to share things, or you want to just talk about your personal project, just let me know and then we'll share on the Slack channel. I will post the link again on Twitter and on the Meetup page. And yeah, and I think that's it. Thank you so much for coming. And hopefully we have another Meetup next month soon. Thank you, Polyfill, for live streaming. Yeah, that's it. And there are more pizza and more beers if you want to. Yeah.
My name's Alex Chandler, I'm a mentor here at the Cancer Data Dive.
We're looking for people to come up with innovative ideas or solutions to the use of cancer data in Scotland.
So we had a Future Health Product Forge back in January. It was really, really interesting. It was such a great environment and it always amazes me how much happens.
It was great to build on the success of the last Product Forge event that I went to. It's great to see so many people that I recognise, including colleagues that are back. And it's so exciting to be able to combine the open data that we released for that event with the addition of synthetic data.
I'm really enjoying it. I've got a solid team, got a good idea I think, and we're making good progress. Our team's fairly diverse, so I've been to previous hackathons where it was just developers and you don't quite get the industry experience or the industry perspectives because of that.
So when you get to work with other people, get a range of insights, a range of more connections, your hunch actually turns into something else.
I think we're working pretty well together. We all come from quite different levels of knowledge of cancer and data. I think together we're creating something good.
I was really keen to come along. What I'm surprised about is how quickly the teams have really got to grips with the challenges that people like us face. That's amazing, that's been great.
No, I've never been to a hackathon before. The teams have some brilliant ideas and they're all so passionate about it, which is amazing considering most of them only met last night.
And this one is more structured in terms of the way that the teams have been bonding.
And also you get more knowledge on what other technologies can be applied in your field.
This kind of intensive innovation is just new to me. I just think this kind of environment is probably really good at breeding, creativity.
I think a lot of the ideas they came up with in the first 10 minutes are actually good ideas.
We find a good idea and we are going for it, and I feel it's going to make a change.
The great thing about these events is where would I meet these people, this range of skill sets. We've met some really interesting mentors who've come around today, some people who are real experts in their field.
Hello, my name's Simon Tolhurst. I'm the portrait artist in residence at the UCLA. I visit the cancer centre to daycare once per week in order to draw the patients whilst they're having chemo, and I hope that the work that I brought up to show the people here, it helps them to connect to the people at the other end of those treatments.
I'm really enjoying myself. It's really fun. It's fun to hear about ideas, it's fun to brainstorm, it's fun to meet new people, and also helping people is really rewarding. So yeah, I'm really enjoying myself.
I'm really looking forward to see what comes out of it.
My name's Alex Chandler, I'm a mentor here at the Cancer Data Dive.
We're looking for people to come up with innovative ideas or solutions to the use of cancer data in Scotland.
So we had a Future Health Product Forge back in January. It was really, really interesting. It was such a great environment and it always amazes me how much happens.
It was great to build on the success of the last Product Forge event that I went to. It's great to see so many people that I recognise, including colleagues that are back. And it's so exciting to be able to combine the open data that we released for that event with the addition of synthetic data.
I'm really enjoying it. I've got a solid team, got a good idea I think, and we're making good progress. Our team's fairly diverse, so I've been to previous hackathons where it was just developers and you don't quite get the industry experience or the industry perspectives because of that.
So when you get to work with other people, get a range of insights, a range of more connections, your hunch actually turns into something else.
I think we're working pretty well together. We all come from quite different levels of knowledge of cancer and data. I think together we're creating something good.
I was really keen to come along. What I'm surprised about is how quickly the teams have really got to grips with the challenges that people like us face. That's amazing, that's been great.
No, I've never been to a hackathon before. The teams have some brilliant ideas and they're all so passionate about it, which is amazing considering most of them only met last night.
And this one is more structured in terms of the way that the teams have been bonding.
And also you get more knowledge on what other technologies can be applied in your field.
This kind of intensive innovation is just new to me. I just think this kind of environment is probably really good at breeding, creativity.
I think a lot of the ideas they came up with in the first 10 minutes are actually good ideas.
We find a good idea and we are going for it, and I feel it's going to make a change.
The great thing about these events is where would I meet these people, this range of skill sets. We've met some really interesting mentors who have come around today, some people who are real experts in their field.
Hello, my name's Simon Tolhurst. I'm the portrait artist in residence at the UCLA. I visit the cancer centre to daycare once per week in order to draw the patients whilst they're having chemo, and I hope that the work that I brought up to show the people here, it helps them to connect to the people at the other end of those treatments.
I'm really enjoying myself. It's really fun. It's fun to hear about ideas, it's fun to brainstorm, it's fun to meet new people, and also helping people is really rewarding. So yeah, I'm really enjoying myself.
I'm really looking forward to see what comes out of it.
My name's Alex Chandler, I'm a mentor here at the Cancer Data Dive.
We're looking for people to come up with innovative ideas or solutions to the use of cancer data in Scotland.
So we had a Future Health Product Forge back in January. It was really, really interesting. It was such a great environment, and it always amazes me how much happens.
It was great to build on the success of the last Product Forge event that I went to. It's great to see so many people that I recognise, including colleagues that are back. And it's so exciting to be able to combine the open data that we released for that event with the addition of synthetic data.
I'm really enjoying it. I've got a solid team, got a good idea I think, and we're making good progress. Our team's fairly diverse, so I've been to previous hackathons where it was just developers, and you don't quite get the industry experience or the industry perspectives because of that.
So when you get to work with other people, get a range of insights, a range of more connections, your hunch actually turns into something else.
I think we're working pretty well together. We all come from quite different levels of knowledge of cancer and data. I think together we're creating something good.
So I was really keen to come along. What I'm surprised about is how quickly the teams have really got to grips with the challenges that people like us face. That's amazing, that's been great.
No, I've never been to a hackathon before. The teams have some brilliant ideas and they're all so passionate about it, which is amazing considering most of them only met last night.
And this one is more structured in terms of the way that the teams have been bonding.
And also you get more knowledge on what other technologies can be applied in your field.
This kind of intensive innovation is just new to me. I just think this kind of environment is probably really good at breeding, creativity.
I think a lot of the ideas they came up with in the first 10 minutes are actually good ideas.
We find a good idea and we are going for it, and I feel it's going to make a change.
The great thing about these events is where would I meet these people, this range of skill sets. We've met some really interesting mentors who have come around today, some people who are real experts in their field.
Hello, my name's Simon Tolhurst. I'm the portrait artist in residence at the UCLA. I visit the cancer centre to daycare once per week in order to draw the patients whilst they're having chemo, and I hope that the work that I brought up to show the people here, it helps them to connect to the people at the other end of those treatments.
I'm really enjoying myself. It's really fun. It's fun to hear about ideas, it's fun to brainstorm, it's fun to meet new people, and also helping people is really rewarding. So yeah, I'm really enjoying myself.
I'm really looking forward to see what comes out of it.